Good evening, ladies and gentlemen. We are continuing with Unit 11 and we're moving into the second half of the unit. So the first half of the unit is on conversions, U.S. customary measurements, and the metric system measurement conversions. And now the second half of the unit is on something called line plots. So our goal is today that we're going to use a line plot to help me solve a multi-step word problem. Okay, so what is a line plot? A line plot just displays a set of data on a number line, and each X represents one piece of data. So this is kind of an example of a of a line plot. Usually a line plot will have some sort of title. Usually it will have a scale. So this is the scale. So this one's going by fourths, and it begins at 2/4 and goes to 7/4. So this is what we call the scale, what it's counting by. And then these X's each represent one piece of data. So each X is a piece of data. So this line plot has 1, 2, 3, 4, 5, 6, 7, 8 pieces of data in it. Okay, so into this lesson, you're going to be learning how to pretty much create these and then to use them to help you. Okay, so our steps today are, first, we're going to read and understand the word problem. We're going to have to read carefully because many of these word problems have little tricks in them. Then we're going to find common denominators. You won't need to do that for all your problems, just for the ones that don't already have common denominators. Then you're going to circle the least and the greatest number. What this is going to do for you is it's going to tell you where do you want to start your line plot and where does your line plot need to go to. So you want to start at the least number and then go to the largest number. Okay, next you're going to create the line plot and do not skip numbers. So in this line plot up here, even though they didn't have a piece of data on 5/4, the scale was counting by fourths, so we just continued. We went 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. So your scale continues. You don't skip 5/4 just because you don't have data for it. Okay, then we're going to add an X for each piece of data, and we're going to cross off as you go. Excuse me. Some of your problems are going to have up to 14 pieces of data, so crossing off as you go will help eliminate you forgetting some. And then you're going to solve using addition or multiplication. And you're not going to convert to the end. I'll show this when I show you the problems and we'll explain why. This will just create more work for you if you do it during the problem. And then you're going to solve your word problem. Okay, so what does this really look like? Okay, let's get my steps put up so we can attack one. Okay, so here's my first word problem. My first word problem says, Renee had a packet of pipe cleaners cut at different lengths for an art project. The data below shows the different lengths of the pipe cleaners in inches. How many inches of pipe cleaner does she have? Okay, so you actually could solve this without the line plot, but they will require you to create one. Okay, so what is this saying? Hopefully we all know what a pipe cleaner is. It's those long, bendable, kind of fuzzy things that we use for arts and crafts, and they come in all different colors. So she cut them, and what the problem is saying is here's the lengths, and they just want to know how many does she have in all. Okay, so that's pretty much what the word problem is telling me. Next, I'm going to find common denominators. Well, I see a denominator 4, 8, 4, 4, 8, 8, 8, 4, 4, 8. Well, if I think about when I added and subtracted, 4 and 8, the LCM or LCD is going to be 8. So I'm going to need to change those to eighths. So what is 5 and 1/4? Well, I could do some side work. So 5 and 1/4 is the same as 5 and how many eighths? Well, 4 times 2 is 8, so 1 times 2. So instead of saying 5 and 1/4, I'm going to say 5 and 2/8. Okay, this one's good, this one's not. 5 and 2/4 is the same as 5 and how many eighths? Well, 4 times 2 is 8, so 2 times 2 is 4. So instead of that, I'm going to change that one. I already figured out that 5 and 1/4 is 5 and 2/8. 6/8, 5/8, 4/8, 2/4 we already figured out. So instead we're going to change it. 1/4 we already figured out. And then eighths. Okay, so that was my step. I changed them all to have the same denominator. Okay, what's my next step say to? Circle the least and the greatest. So of these numbers, what's the smallest? Is anything smaller than 5 and 2/8? Well, I don't see anything smaller. And then what's my greatest number? What is my greatest number? It looks to me that it's going to be 5 and 6/8. So let's circle that. Okay, so that tells you what your scale is going to be. So my scale is going to go from 5 and 2/8 to go to 5 and 6/8. So I'm going to have to come over here. So my first one needs to be 5 and 2/8. And my last one I need to be 5 and 6/8. So what am I counting by? I'm counting by eighths. So I'm going to have 5 and 3/8, 5 and 4/8, 5 and 5/8. Okay, so my scale is counting by eighths. Okay, let's look at and I did little dashes to help me. Let's look at our next step. Create your line plot, do not skip the numbers. I already did that. Now I'm going to add an X for each piece of data. Okay, so each piece of data. So I have a 5 and 2/8. Do I have any other 5? I have 2 5 and 2/8, 3 5 and 2/8. So ready? 1, 2, 3. Okay, then I have a 5 and 6/8. Any more? 2 5 and 6/8. That's it. So I'm going to put 2 X's. Then I have a 5 and 4/8. Do I have any others? 2 of them, 3 of them. Okay, so 1, 2, 3. And then I have a 5 and 5/8 and another one. So I had 2 5 and 5/8. Okay, so I crossed them off as I counted them, and then I put an X for each one. Okay, then it says solve using addition or subtraction. So what does this actually equal? Well, if I have 3 5s, because that's what this is saying, I have 3 5 and 2/8. Well, 3 5s is 15. And what are 3 2/8? Well, 3 times 2 would be 6/8. So this is the same as 15 and 6/8. So I used multiplication. I just said I'm going to have 2/8 plus 2/8 plus 2/8. You also could have actually written out 2/8 plus 2/8 and figured out it's going to be 15 and 6/8. Okay, here I have nothing. Here I have 1, 2, 3 5s, which is 15. And I have 1, 2, 3 4s. So 4 times 3 is going to be 12/8. So I'm just adding that up. Now you won't need to do this, but I'm going to show you what I'm really doing. I really have 3 5 and 4/8. Sorry, my 8s are getting sloppy there. So 4 plus 4 plus 4 is 12/8, and 5 plus 5 plus 5 is 15. So this is what I was doing. I'm just doing a lot of it in my head. Okay, here I have 2 5s, which is 10, and I have 2 5/8. So 5/8 plus 5/8 would be 10/8. And here I have 2 5s again, and I have 2 6/8. So 6/8 plus 6/8 is 12/8. Okay, now I need to add all these up. So how many whole numbers do I have? Let's see. 15 plus 15 is 30, 40, 50. Okay, 6/8 plus 12/8. And if you can't do this in your head, you could list it out. 6 plus 12 is 18. Plus 10 is 28. And plus 12 is 48. So far I have that. So notice I never fixed any of my improper fractions. Now that I'm done, now I can actually fix my improper fractions. So 8 can go into 45 times. So 48 is the same as 5, and I already had 50, so my answer is 55. So my original question now said, how many inches of pipe cleaners does she have? She has 55 inches of pipe cleaner. Okay, let's look at another one. Okay, this one says, Lydia wants to exercise a total of 10 hours this week. Based on the line plot that shows the hours worked out at each station of a workout circuit, did she meet her goal? So they want me to add these and see if she actually met her 10 hours. Okay, so my steps say I read it and understood it. Then it says to find common denominators. But in this problem, they all have halves, so I can skip that. My next step says I'm going to find the least and the greatest. So 1's my smallest, and 3.5's my greatest. So now it says create your line plot and do not skip numbers. So it seems like my scale is counting by halves here. So I'm going to have 1 and I have to end at 3.5. So I'm counting by halves. So 1.5, 2, 2.5, 3. So there is my scale counting by halves, and I didn't skip numbers. Let's look at our steps and see what we're going to do next. Okay, so next it says I'm going to add an X for each piece of data and cross off as I go. So I have 1, 2, 3 1s, 1, 2, 3 1s, 1, just 1 2.5, 1, 2, ooh, I made a mistake. Half was my smallest number. Do I have to start over? Nope. All I could do is realize I needed 2 halves, so I could come over here and add those 2 halves. So if you make a mistake like that, you just come right over and fix it. Okay, and then 3.5. Okay, so I have created all mine. Sometimes it's a good idea, especially if you make a mistake, to go back and check. You should have 1, 2, 3, 4, 5, 6, 7 pieces of data. And I have 1, 2, 3, 4, 5, 6, 7 pieces of data. Okay, so now I'm ready to add. So I have a half and a half. So 2 halves equals 1. 1, 2, 3 1s equals 3. 1 2.5 just equals 2.5. 1 3.5 just equals 3.5. So how many whole numbers do I have? 1 plus 3 is 4, 5, 6, 7, 8, 9. And I have a half plus a half, which is 2 halves, which is the same as 10. So let's look back at my question. What did my question ask? My question said that she wants to exercise for 10 hours. Did she meet her goal? Yes, she did meet her goal. So our answer is a yes. Okay, ladies and gentlemen, grab your pencil and let's try some of these together. Okay, here's our first problem. And it says, Mrs. Roderick gave each of her 9 students a cup of lemonade with different quantities in each of them. If she serves the same quantity one more time to each child, how much lemonade will she have in all? Okay, so what this is saying is she gave her 9 students this lemonade, but then it says she gave them the same quantity again. So we'll have to remember that later on. Okay, so you should have your steps out. It says first to fix our denominators, but all my denominators end in eighths. So I'm good with that. My next step then says that we need to circle the least and circle the greatest. So what is the least and the greatest? Well, I see a 5/8 is my least, and my greatest is 1. Lucky student 1 got a lot. Okay, so I'm going to start with 5/8, and I'm going to end with 1. And it looks like I'm counting by eighths. So 6/8, 7/8, and then 1 is the same as 8/8. Those are equal. Okay, my next step says I'm going to plot them. So let's see, I have 1, 1. I have a 6/8 plus another 2, 3, 4, 4 6/8. I have 1, 2, 3 7/8. And I have 1 5/8. And again, if you want to count your data, there's 9 students, so I should have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data. Okay, so now let's use multiplication and addition to help us. This is 1 5/8 equals 5/8. And this is 1, 2, 3, 4 6/8. So what's 4 times 6? 24/8. This is 1, 2, 3 7/8. So it's 7/8 plus 7/8 plus 7/8, which is the same as 3 times 7 is 21/8. And then this is just 8/8. Okay, so now we have to add them together. And this is a lot of big numbers, so you might want to write them on the side maybe. So I have 5 plus 24 plus 21 plus 8. So I'm getting 9, 10, 18 plus 1. I'm getting 58/8. Okay, but I'm not quite done because remember they said in the problem that she poured all of them and then she gave them all another one. So I really have 58/8 plus the second pouring would be another 58/8. So when I add that, what is 58 plus 58? I'm getting 116/8. Okay, because she gave them a second serving. So now that I'm done, now I can fix my improper fractions. So 8 can go into 116 one time, and I get a 3. 8 can go into 36 4 times. 4 times 8 is 32. And then I get 4. Remember, I bring that up. It's really squished here. So I'm getting 14 4/8, which is the same as 14 1/2. So if every child got 2 servings, that's what she would end up needing to have enough lemonade. Okay, let's try one more together. So my next problem says, Max measures 7 sticks he found on a hike. 3 sticks measure 2 1/2 inches, 2 sticks measure 1 1/4 inches, and 2 sticks measure 2 inches. If he needs 42 inches of sticks to make a model log cabin, how many of these same sets of sticks should he find? Okay, so for this one, they actually provided the number line for my line plot. So we just need to add our little dashes before we begin. Okay, and then we can start our steps. So my next step says, after I've read it, that I need to make sure they have the same denominator. Well, this one says 2 1/2. This one says 1 1/4, and this one says 2. So it seems like I need to have, if I have a denominator of 2 and 4, I'm probably going to need to change the 2 1/2. So 2 1/2 equals how many fourths? Well, if I move this down a little so you can see, 2 times 2 equals 4, so 1 times 2 is 2. So instead of 2 1/2, I'm going to say 2 2/4. Now my denominators are the same. Okay, so this one, because they've already set this up, I don't need to create it. I just need to add my pieces of data. So it says he has 7 sticks. 3 sticks measure 2 2/4. So 3 of them are at 2 2/4. 2 sticks measure 1 1/4. So he has 2 this long. And 2 sticks measure 2 inches. So there's his 3, 4, 5, 6, 7 sticks. Okay, so let's add these. So 2 1s is 2, and 2 1/4 is 1/4 plus 1/4 is 2/4. 2 2s is just 4. I'm sorry, 2 2s is just 2. I keep making a mistake. 2 2s is 4. Okay, 3 2s is 6, and 3 2/4 is 3 times 2, which is 6/4. Or you could have said 2/4 plus 2/4 plus 2/4. Okay, so if we add up those lengths, what do we get? We get 2 plus 4 is 6, plus 6 is 12, and 2/4 plus 6/4 is 8/4. So I could take that and say 4 can go into 8 2 times. So 12 and 8/4 is really the same as 14. So his first set of sticks is 14 inches long. Okay, so let's go back to our question and see what it's asking us. Max measures 7 sticks he found on a hike. 3 sticks measure 2 2/4. 2 sticks measure 1 1/4. And 2 sticks measure 2 inches. If he needs 42 inches of sticks to make a model log cabin, how many of these same sets of sticks should he find? Okay, well, one set gave him 14 inches. So if he has 2 sets, he'll have 28 inches. That's not enough. If he has 3 sets and each one's 14 long, let's see what happens if I say 28 plus 14. That will give him 42 inches. So our answer is he needs 3 sets of sticks. Okay, ladies and gentlemen, this page or set of homework had 3 pages. So you have a whole homework page with 2 problems, and of course rate your understanding. Have a good evening. Good night.